Hi everyone, welcome to the Developer Fest Cloud Native series. And today we have the SAP BTP Kyma Runtime Day-2 operation session 1. So let's right now jump in and then see what we have. But before we go, just a brief introduction about myself. Yeah, so I'm a part of the product management in SAP. Working as a technology evangelist and a product expert. So my mission is to help customers, partners, and also internal teams succeed in their cloud native journey. So you can reach me at any of these social media. So I prefer the SAP profile. So in case you have any questions, any discussion, please reach out to me there. I'm glad to help and then discuss any topics with you regarding cloud native. Okay, so this is the outline of the session that we have planned today. So first, since we are talking about day-2 operations, first we need to understand the separation of the concerns. So by that, what I mean is we need to understand when SAP provides you a managed schema runtime, what are the responsibilities it has on its side and what are the expectations from the customer or a developer. So we need to just clarify that a bit. And then moving forward, we will see that what all is provided out of the box to help the customers and developers do the work on their side. So what kind of observability tools are available? So what kind of monitoring capabilities are there? And what you can do for the alerting part. Yeah, in case you need to set up some alerts for your applications, for your workloads. So what would be the way forward for achieving such a scenario? Yeah, then moving forward, we'll also have a look at your customer data and the backups and the recovery part. So in case you set up some workloads where you are storing some data, you would also like to ensure that in case of some kind of a disaster, there is a possibility to do some kind of a recovery. And we'll see that what are the options for achieving that. Last but not the least, we will see when you are done with your business application, you have done developing it, and now you are ready to go live. So you'd like to have some kind of automation there, so that whenever basically there is a new commit coming, new feature coming to your application, it should be seamlessly becoming a part of your live setup. So we'll see that for the CI/CD, what are the options are there and what all things and how you can use them. Okay, so let's go further. So we'll first have a look at the full stack for the Kyma runtime. This is important to understand that when you purchase a managed Kyma runtime from SAP, so what all is included in that? So as you can see that it's basically a Kubernetes cluster. So we provision a Kubernetes cluster via Gardener, which is another open source project coming from SAP itself. You have the option to deploy the Kyma runtime on one of the 3 hyperscalers that we offer currently, so AWS, GCP, and Microsoft. And inside the Kyma runtime, you see that we have various components that help you basically achieve your integration and also extensibility scenarios with SAP solutions. So in case you want to extend some SAP solutions or you want to host some applications on there, so there are other components which are help you consume the BTP service and also help you run your applications in a seamless way. So for example, let's start with eventing. So in case you need to basically listen to some events for your SAP solutions, or also need to generate some events internally for some kind of asynchronous workflow. So there is an eventing component in Kyma that takes care of helping you achieve your requirements there. Then there is observability part. We'll also look into detail for that. So there is a Loki component that takes care of providing the logs so that you can troubleshoot some errors, some scenarios for your functions and for your microservices. Then for the metrics part, there is Grafana and Prometheus stack that takes care of providing you the metrics there. And Kyma itself comes with the Istio service mesh so that a lot of your so to call these use and read metrics, basically the HTTP metrics, the volume and the error rate and others, they are available to you by default. We will also see that in a while. But yeah, just to give an idea that there are a lot of benefits of using the service mesh. So also basically having the mutual TLS communication between your microservices that are deployed on the Kyma runtime. Then there is a lightweight component that helps you build functions. So in case you basically have a some kind of a very simple scenario or some code that is not that big or not that complex, you can think of also using the functions. So they will take care of creating a deployment and everything for you. So you just need to focus on writing a function for you. So basically, you just focus on writing the code, but you don't need to take care of building a Docker image or deploying a container and all the stuff. So that is taken care by the Kyma itself. Then again, yeah, in case you have some complex applications, some domain-driven logic that encompasses multiple files, you can consider building microservices, create a Docker image, and deploy a Docker container on top of that. For exposing the applications over the internet, you have the option to use the API gateway. So basically, you can expose the application, you can secure it with a custom identity provider, or you can secure it with the auth server that comes with the Kyma runtime itself. For connecting to the SAP applications, there is a component called application connector. So it takes care of automatically or ensuring that you are able to connect to your SAP applications with very few configurations and very few clicks. So if you have already seen some examples of connecting, for example, a Commerce Cloud or maybe a cloud for customer, you can see that basically the flow is quite straightforward, and all this is achieved by virtue of using this application connector as a part of the Kyma runtime. Then for the security part, since I already mentioned that we use the OpenID, and also there is a possibility to use the SAP IS or Access UA. So this all is coming via the federation, the integration that we have with all these components. Regarding the service consumption, first and foremost, it is possible to consume the various BTP services that are consumable from the Kyma runtime via this operator model. So there is a BTP operator that gets deployed as a part of the Kyma runtime. It ensures that you can consume services like destination service or credential store or some other services directly from the Kyma runtime itself. So you not only consume the service, but you also manage the lifecycle of these services directly from the Kyma runtime. So from the Kyma itself, you can create an instance of the service, and also you can create the bindings and then use the secrets with your functions and microservices. Similarly, there is also a possibility to consume the services coming from the hyperscalers. For that, you need to bring your own subscription for the hyperscaler, but using the operators that are provided by these hyperscalers, you can create the instance of, for example, some Microsoft service directly from your Kyma runtime. So in case you require to do that, that is also possible, and the flow is very straightforward. In case, you can have there are some blogs out there regarding this. So in case you need to check that out, just have a look at some of those blogs. That will be really useful. Okay, so let's start with our agenda topics. First part, the separation of concerns. So as we saw that what all is in the part of the Kyma runtime. So it is a Kubernetes plus X, and X is all those features that we just have a brief look there. So from the SAP side, it is basically a responsibility of SAP to ensure that apart from the Kyma runtime itself, all those components are up and running. They are always live. So we have a 24/7 enterprise support. So whenever there is a problem in any of these components, our SREs get notified, and then they take care of fixing the issues and ensuring that your Kyma components and your Kyma runtime itself always stays in a healthy and working state. Now, the expectations from the developers and the workloads or the customers is that they take care of ensuring that their workloads are always running. So whenever you deploy a function or a microservice, in case there is a basically a logical error or a coding error, or in case there is a problem with the, let's say, the resource consumption, so this is something that you need to take care on your side. You need to ensure that your application is business-wise, logic-wise correct, and also it has enough resources so that it can run correctly. So if you deploy a Java application and you provide it too less CPU or too less memory, it can start throwing out of memory error. In that case, you need to fix it and ensure that the resources that are configured for it matches what is required for running this application in a successful way. Okay. So let's now look at some of the components of observability that can help you ensuring that your applications and also up and running, and you are aware of the state of your Kyma cluster. Okay, so in the observability, we'll talk about the monitoring first. So there are a lot of out-of-the-box dashboards that can help you basically keep an eye on your Kyma cluster, and also at the same time troubleshoot and fix or understand various problems. So for example, if in case you have questions like how much or how my services are performing. So what is the latency? What's the volume? What's the success rate? Are there any errors? Am I basically having my services too slow, or which components are causing that problems? So for that, you can always refer to those dashboards. Similarly, regarding the health, you can have a look at the resource usage. So in case you have deployed an application or a pod, and then you see that, or you are interested in understanding how much memory is currently consumed or how much is configured by you. So you can kind of always compare it and see that if what I have configured as a request or as a limit, if it is matching with the actual usage of my application or not. So all those things are very important. I'm just like especially mentioning here CPU throttling. So that's kind of something that we have seen as an experience with certain scenarios. In case you configure a really low CPU request or a limit for your application, it could happen that the Kubernetes will start throttling the CPU for your application. In case it needs more threads or more CPU, the end result would be that your request will be served in a slow or the latency will be quite high. And please ensure that if you see certain kind of these kind of problems, that your application is not getting CPU throttle. So if you look at the one of the dashboards for the pod, so there is a separate section to show you why the CPU, if the CPU throttled or not. Yeah, so you can always have a look at that and understand that if that is a root cause why my application is kind of behaving in a slow fashion. Okay, so let's jump actually into the dashboards. So I have also slides there, but I think it's better that we can have a look at them, the dashboards live. So I'm going to just go into my browser. So for now, I am basically exposing my dashboards locally. So I have here, basically I did a port forward for my Grafana that is running in my Kyma cluster. And then I'm going to access it locally from my browser itself. So let's first have a look at some of the Kubernetes dashboards. So if I just type Kubernetes, I can see there is a whole lot of dashboards that are available to me. So they give you various set of information from different perspectives. So in case if you just check this out, this Kubernetes cluster dashboard, so you can see how overall your cluster is performing. So in my case, I have a cluster where the CPU utilization is around 21%. But the requests are around 70%. So this means that all the components which I have deployed on the Kyma runtime, along with the components coming from the Kyma itself, they are reserving this much of CPU. So there is a way in Kubernetes you can reserve the particular CPU. That is via this request specification. So you are basically declaring that for each application, I want this much of CPU. Then that total is around 70% of the total CPU that is available to my cluster. But if you see, the limits are quite high. So limits can be higher because in the end, you are not expecting every application to go and reach that particular limit. But it's important to keep an eye for each and every application to understand that they are not getting throttled or they are not always hitting the limits. Then you need to maybe go and adjust the value for your request here. Similarly, for the memory utilization and memory request, we can have the same thing. So I can have a CPU usage, and here I can see the CPU usage and everything for each of my namespaces. If I drill down, I can also see it at each application level. So if I just maybe go to one of let's go to the mocks. So I can always go here. I can see how my pods are behaving in this particular namespace. And then I can also go for a particular pod there. So if I can go to this pod, I can see the exact details of how this particular pod or application is behaving. So in case you can see the CPU usage here. And yeah, as I mentioned, this is also interesting to know that we can see what is happening with the CPU throttling. So in this case, you can see that around this time, there was a bit of a CPU throttling that happened. That means that I need to go and adjust my applications in a way that I should not see any CPU throttling for my applications here. Because then I know that I'm able to serve the latency in a better way. So yeah, this is like one of the dashboards that you can look from a Kubernetes perspective. The other set of dashboards that are also really important and also provided as a out of the box from Kyma are the Istio dashboards. So if you just type Istio, yeah, you can see there are certain dashboards that give you overall information about your mesh, your performance. There's a Istio service dashboard and Istio workload. The one thing that I really find very useful and kind of helpful is the Istio service dashboard. It gives you the the various basically numbers about your service from HTTP perspective, how the request is behaving, what is the error rate, what's the success rate, what's the latency. So you can just simply select your service. In my case, I have a app router running here. So I'm just going to select that. And once I look at this, let me just extend the time to maybe the last 30 minutes. Let's see. I'm just going to focus on this part because this is where I kind of simulated some of the load here. So here you can see that what is the request volume. Yeah, it's not showing this because it's in the past, but you will see some value when you have a continuous volume there. You can also see the success rate here. It's 100%. That means that my application is healthy. There are no functional or any other errors there. And I can also look at how my latency is there for this particular application. Yeah, so I can see the latency numbers are around 50 milliseconds for the 99th percentile, which is kind of acceptable. That's what I was kind of hoping for. So this dashboard gets it provided for you out of the box. So you are not configuring anything for getting this information. You just are ensuring that your workload is configured with a sidecar, and the sidecar or the Istios proxy takes care of generating all the metrics for you. You are not even writing a single line of code for getting all the metrics for your application there. So that's kind of one of the, I would say, the positive side effects of using a sidecar as a part of the Kyma runtime, or service mesh or the Istio service mesh as a part of the Kyma runtime. Okay, so this is mostly about the Istio dashboards, and I think you should find that useful and quite helpful. The other dashboards that are also quite important are the ones related to the eventing. So if I just look for the eventing dashboards, I can see that there is a dashboard for the delivery of the events. So if I just go inside this one, again, I just simulated some events up, so I'm going to focus on that part here. So I can see that how many events are coming inside my Kyma runtime. So if you have some SAP solutions connected to your Kyma runtime, and from there you are sending some business events, maybe to just give an example, there could be an event when a web shop, there is some kind of order that is created, someone does some kind of a purchase, or for a Cloud for customer, there could be some kind of a opportunity created or a service ticket created, and you want to capture that event and then maybe do some extension logic on top of that. So for all those events, they are coming via this component called Central Application Connectivity Validator. So here you can see that what's the rate of the events they are coming, and if they are successfully getting stored in the database or not, or the broker or not. And here you can see again, these events are getting forwarded to this event publisher from where they are getting stored. So I can basically see a lot of kind of an overview about my events, like what's happening there. That's like the one part. The other part is once my events entered the Kyma runtime, you will also be interested in to see that how they are getting consumed by your application. So in case you have built a function or a microservice that is supposed to listen to this event and then react on that, you will also be interested to know that what kind of how those subscribers are acting. So that's where this event delivery per subscription dashboard becomes very useful. So if I just go here, I can see that, I'm just going to focus on the part where I just generated some load. So I can see that what's the rate of the successful events. So there are no failures there. That means that all my events are getting successfully consumed. And after that, I can see the successful event delivery per subscription. So I can see that what's the rate of at which events are getting consumed by various subscriptions here. That's quite useful. The other thing that kind of gives you overview is that for each event type, what's the response code I'm getting from a particular subscription. So basically, I can see that for all these my subscriptions, I'm getting always 200. So, and I can also see that how many events are getting sent here. Just kind of a overview, but it's quite useful because we have seen sometime there are issues where there were complaints that, hey, my events are not coming or my events are missing. So when you look at these dashboards, they can tell you a very nice true story, what is happening there. It could be the case that your subscription is throwing some kind of a 500 error, and that's why your events are not getting consumed. So this kind of is already an indicator that maybe you need to go and fix your business logic, or maybe you configured your subscription wrongly. You configured it to an endpoint which does not exist. So then also you will see the errors, but then it's important to know that, there are some metrics and dashboards there that can help you understand what's and why it's behaving the way it's behaving currently. Okay, So if you want to basically maybe go a bit deep, we can also get some information about how the events are getting stored and processed at the database level or the broker level. So by default, the Kyma eventing use something called as a Nats Jetstream as the eventing or the messaging broker. So basically, it's similar to something like ActiveMQ. So you can think of Kafka and ActiveMQ and then Nats in that fashion. So Nats is one of the alternates here that we are using. It's quite lightweight. There is also option to use the SAP event mesh, but by default, you always are configured with the event stream. So it's possible to switch that to something like SAP event mesh. But yeah, here we are using the jet stream there. And here also you can have a look at how my events are getting stored, how they're getting published or stored inside a database, and how they're processed from the database itself. So you can see some of the stream data that is coming here. And then you can see the consumer metrics, basically how the events are getting pushed from this database to your consumers. And the really important dashboards are these pending messages and the message X pending. So basically, in case there are some problems with your consumption of the events, you will see that there is a graph that is continuously increasing. That's already an indicator that there is something wrong with the way your events are getting consumed. Either your application is misbehaving, or there is something wrong with the endpoint, or there could be some other problem with the consumption of the events. And also you can see the message expanding. So whenever an event is sent from the database to the subscriber, it waits for an acknowledgement back from the subscriber, which is basically the HTTP response 200 that tells you that the subscriber, the event is successfully consumed. So that's how then it removes that message because it has been consumed. And this is quite important. If your application is not sending the acknowledgements, then the database will kind of assume that the events are not consumed, and it will keep on retrying those events. So it's quite important to also send the proper response back so that you can tell the database or the broker that the events are getting consumed successfully and it's okay to move or delete them. Yeah. So these are not all the dashboards, and there is a lot of information here. And I would highly recommend that whenever you have some questions about what's happening with my Kyma cluster, or if I want to get some kind of information, I would always recommend to go and check in the Grafana part and see that if there is already some dashboard that can help you understand or get the information you are looking for. Yep. So just going back to the presentation now. So we talked about the Kubernetes dashboards. Yeah, then we talked about the Istio part. We saw that how we can use the Istio service dashboards for understanding how my service is behaving. And we talked about some of the eventing dashboards. Okay, so now let's talk about what are the things that you need to maybe do by yourself. So first and foremost, at present in Kyma, there is basically no option to have some kind of a custom metrics. So in case you want to have some kind of a custom metrics like how many users got created or how many orders got processed, so for that, you need to bring your own monitoring stack. You can either use some of the third-party solutions like Dynatrace, or you can also consider deploying your own Prometheus inside and operating it by yourself. So currently, we don't support the custom metrics. The reason being that we provide this our own Prometheus out of the box, and we want to ensure that it's always up and running, because then we can monitor all the Kyma components. But because if we open the option for the custom metrics, then it could be quite resource intensive, and it might lead to stability issues. So that's why we restrict only to custom metrics. And you can use maybe something like a Prometheus operator to deploy your own Prometheus runtime, or you can directly install it as a standard stateful set or deployment or whatever it recommends. Yeah. Similarly, I think for the alerts, so again, for the alerting, you can consider using some kind of a third-party service. So for example, you can deploy or integrate with Dynatrace and then do the alerting from there, for example. Or you can deploy your own alert manager and Prometheus together. So they can help you send some alerts for your workloads. So for the Kyma services or Kyma components, there are already alerts that are being sent and taken care of. But for your workloads, you need to maybe for at present deploy something by yourself. So there is a very nice Day-2 operations mission in the Discovery Center. I have put a link here. I think we also shared that in the in the YouTube chat. So you can always have a look at that. It provides you all the steps how you can deploy your own Prometheus, how you can integrate with Dynatrace, or how you can, in the future, how you can always even integrate with the Alert Manager. Okay, so that was mostly about the observability part, and now we can talk a bit about the backup and the recovery part. So first and foremost, we need to understand why we need to do a backup, because we can have certain applications that might have some kind of a storage. So it could be possible that you have a scenario where you're writing or storing some files, or maybe running a lightweight Redis inside the Kyma cluster, or any other scenario. So there could be multiple scenarios where you might be requiring some kind of storage for your data. So all those scenarios, that means that you might be using some kind of a stateful set or a deployment, and then attaching a persistence volume claim. So behind the scenes, this persistent volume claim, it kind of configures a hyperscaler disk, and then it stores the data there. So that is all fine. But there can be scenarios where your data might get, I don't know, corrupted, or there can be disaster scenarios where we need to recover that data for you. So in those kind of cases, basically, you need to have some kind of a backup and recovery strategy. So there is a concept of volume snapshots inside the Kyma runtime, or in the Kubernetes in general. So you can use this concept of volume snapshots to create the snapshots of your persistent volume claims at certain events. So you can maybe start up a cron job that is creating the volume snapshots every hour, or every 3 hours, or whatever is comfortable or suits your business needs. And then in case you need to recover it, you can take the latest snapshots, and then you can recreate the persistent volume claim out of that. So there is a very nice sample where we do this whole exercise, where we create a volume snapshot, and then after that we delete the original persistent volume claim, and we delete the persistent volume, so the data is gone, and then we recover the data from the snapshot itself. So that's how that's a recommended approach for your workloads, or the data for your workloads to be recovered and then restored. Just one thing to note: for the Kyma components and for all the configurations, you do not need to worry about any kind of a backup and recovery, because that is already taken care by the Kyma runtime itself. You only need to take care of your workloads and the data corresponding to those workloads, in case you are storing some data there. Okay, so we can talk about the CI/CD part, because that's something that's always very close to my heart, and then I always find it quite exciting, because there are a lot of opportunities and a lot of interesting things happening in this space, and we will also look at in a while. So when we think about CI/CD, the conventional CI/CD, in case you have used tools like Jenkins or Circle CI, or maybe, I don't know, something similar, all these tools have this conventional approach where whenever there is a commit, a pipeline gets triggered that will then takes care of pushing the changes or deploying the changes on your runtime environment. It could be, I don't know, some Kubernetes cluster or some other application running on a virtual machine. But the whole approach is something called as a push-based approach. So basically, you are pushing the configuration and the changes to your runtime. So this is what is also possible with the Kyma and Kubernetes. So in the conventional push-based approach, as I mentioned, that you did a push to your Git repository, and then the pipeline ensures that you are able to deploy it on your Kyma runtime, or you are able to update your workloads running on the Kyma runtime itself. So for this kind of a possibility or scenario, there are like various umpteen options available. I'm just naming a few. So you can use something like the SAP CI/CD service itself that works on this approach. Then you can also use GitHub Actions, or you can use Jenkins, or any other third-party tool that is allowing you to publish your changes to a Kubernetes cluster or a Kyma runtime. So we can quickly have a look at one of or few of the examples here. So I'm going to start with the SAP CI/CD here. So I'm already, okay. I need to relog in, but yeah, that's fine. Yeah, so you can see that in the SAP CI/CD service, I have certain jobs that are created. So I have a repository here that is pointing to my particular repo from where I should be getting the changes. And then there are a few credentials that I'm using. So I'm using a Docker credentials to publish my Docker images after building them. Then there is a Kubernetes or kube config, which is basically used for doing something like a kubectl apply or deploying a Helm chart in this case. And then there is a token to basically pull my changes from my GitHub repository. So whenever there are new changes in any of my repositories, the first and foremost thing it does is it kind of builds a new Docker image. So I have here all the configuration parameters for my Docker image here. So you can see that I have mentioned my Docker container registry there, and then what's the name of my image. I can also create a container image automatically. So that's something that the SAP CI/CD service recently added, so that in case you want to have different container image names or different tags based on different commits. So that's also something very much possible. So once my image is built and pushed, the next part would be then to deploy it as a release on the Kyma runtime. So here I'm using the Helm. So I provided my Kubernetes credentials, and then I provided the path of my chart. And after that, yeah, I provide the path of my values, and then it takes care of basically deploying it or updating my Helm chart inside the Kyma cluster. So yeah, that's how it gets deployed there. And after that, whenever you do a new pull, you can always look at your changes and then see that yeah, it's up to date or not. And then yeah, you can have this automation here. Very similarly, you can achieve the same thing with something like GitHub Actions. So I have here one GitHub action that is deploying my changes to my prod namespace. So if we look at this action file here, it's basically doing first a checkout here. That's like nothing different. And after that, it is setting the Kubernetes context. So basically, it is pointing my kubeconfig file so that it can then do a Helm deployment. And after that, I'm just doing a Helm chart here. And yeah, after that, it's just a matter of running this Helm upgrade command and then telling it to basically deploy my application or my Helm chart and install it there. So I'm just saying that do a Helm upgrade, and this is my path of the chart. And here I'm saying that if the Helm chart doesn't exist, then install it first time. Yeah, so nothing's different, but a standard Helm command to continuously deploy my applications whenever there is a particular change. Yeah. So we can also look at this whole application in action. So it's, I think, deployed in my CI/CD prod namespace. So all these resources like the API rules or even the workloads, all my functions, all my deployments here, in this case, they are coming from this GitHub action. Yeah. So that's how basically I'm doing all the automation. So whenever I kind of update it or improve some functionality in this whole application, and then do a git push, then the GitHub actions or even the SAP CI/CD service will automatically get triggered, and then it will apply or deploy my changes back into the Kyma runtime. Yeah, so that's basically the classical push approach. The only thing you need to take care of is that download your kubeconfig from a service account that does not expire, and then upload it into your credentials or secrets in your GitHub actions or any other pipeline, because then that kubeconfig will be used during the runtime by the pipeline to do a kubectl apply or a Helm upgrade or Helm install. Okay, so that's yeah, more or less the push approach. And similarly, as an alternative, we also have something like a pull approach. So this kind of is something new. So if you've already heard about GitOps, you might know about this, but the whole idea is that in this case, as the name suggests, there is no pipeline that is pushing the changes to your runtime, but instead you are running a GitOps controller inside your Kubernetes cluster, and it knows about your GitHub repository, and periodically it is checking for any changes. So whenever you do a new commit and a push, and with its periodic interval, if it detects that there is a change, it will fetch those changes, it will pull those changes, and then it will apply it on your Kyma runtime. So there are like various options there. Some of the very famous open source options are Flux and Argo. So we'll also see one of the examples with Argo just in a moment. But the whole idea is that, yeah, you don't have a pipeline there that is pushing the changes, but you have a controller there that is kind of pulling the changes. So both approaches have their pros and cons depending upon what kind of scenario you are looking for or what tools you are comfortable with. So based on that, you can always decide on one of those approaches to kind of solve your CI/CD solutions. So if you look at example of Argo, so I have also, for example, Argo deployed in my Kubernetes cluster. Let me just confirm that it is still running. It looks live. So let me go and access my Argo application. So again, I've deployed the Argo locally here for me. So I'm going to access it on my local host. Yeah. So let's first go into the application itself. So if I look at the app details, so basically in Argo, you will create a construct called application. So here you will see that in which cluster you want to deploy your Helm chart or your resources. In my case, it was the same cluster where my Argo is running. So that's why it is the in cluster one. Then I mentioned like what namespace I want this to be deployed, this application. And this is where I mentioned my repo URL. So in case you have a private Git repository, you also need to provide the credentials. But in my case, since my repository is public, so I'm not providing any credentials here. And here I mentioned like which branch it should use for pulling all the changes. So mine is something called a central API gateway. I was doing some research in the past, so I'm just using that branch. And this is a path of my Helm chart here. So this is basically the whole story I need to provide, and mostly that's it. So if you now look at all the resources that get deployed, because it provides a very nice UI that can tell you what all is getting deployed there. So we can see that it is deploying a Kubernetes service, a couple of services, in fact. And after that, I can see that it is deploying a Kubernetes deployment, which is again creating the basically the replica sets, and then there is a corresponding pod. And after that, it is deploying again few more deployments, and then there are some event subscriptions that are getting deployed. And then there are certain API rules which are exposing my applications over the internet. So you can see it's like decently complex application. It is not a simple hello world. So that's why you see a lot of resources. But the whole idea is that it gives you a very nice overview of how your resources are getting deployed and what's the state and health of all of these resources. So in case any of the resources are maybe failing or restarting, you will see this heart symbols color changing from green to red, so that you get an idea that there is something wrong there. And this is not the whole story, because the interesting part is that you can directly access the logs from your application from here. So if I go to one of the pods, yeah, maybe let's go to this pod. Let's just let it load. So I can see all the events first of all. So in case there is something happening with my pod, it's continuously restarting, or it is stuck in some kind of a pending state, I will see the events here. And I can also access the logs directly from here. So there won't be much logs, because there is nothing much happening for the past half an hour or 40 minutes. But yeah, the whole idea is that I'm able to access all the details about that, what's happening for my application there. Yeah, there are some for the Redis and there is nothing for the S2 proxy. So you can see some of the details coming here. And you can also basically do some different views. So in case you want to look at like from the top level, or maybe do some kind of a different one. So you can group the resources. For example, you can say that I want to see on what all nodes different applications are deployed, or what all components are deployed, or what are pods. So you can always have a look at that. So quite nice and quite helpful UI in case you want to go with a GitOps approach. Yeah, it's kind of helpful here. That's pretty much about the CI/CD part. Let me just go back to my presentation. And yeah, so this was basically the example applications that I deployed both with the push and a pull-based approach. So for the push-based, I used the GitHub Actions, and then for the pull-based approach, I used something like Argo here. But in both the cases, it deployed these two scenarios into different namespaces. So you can achieve the same kind of setup depending upon which one you want to prefer, or which one kind of you find more comfortable with. You can follow one of the approaches here. So that's pretty much it that we have for today's session. And please let me know if you want to get some more information. If you have some questions, we can always raise them in the session, or always contact me. Okay. Thank you. That's pretty much it.